Hey guys, I wanted to take a couple minutes and show you how to do the secant and the cosecant graphs. They're going to look a little weird at first, but once you actually get the hang of them, they're actually pretty easy to do if you know how to graph sine and cosine graphs, which we already do know how to do that. Big thing to remember when you're doing the secant graph, it's just the reciprocal of the cosine graph. So this is the same thing as 1 over the cosine of x, right? It's just the reciprocal. So if we can graph the cosine, we can definitely graph the secant. So we're actually going to start off by graphing the cosine graph. So if we're graphing cosine, normal cosine graph, I'm going to start up at 1. We know at pi over 2 it's 0. At pi it's -1. 3 pi over 2, 0. We're up at 2 pi back to 1, so that's one period of our function. I'm going to fill in the rest of our points here. You'll notice I'm doing this just in a lighter color right now, because this isn't our actual secant graph. It's just going to help us kind of guide our way to do the secant graph. You may just want to kind of do it a little bit lighter in pencil. Sometimes you'll see us graph it as like a dashed line instead. Again, it's not an asymptote or anything. It's just to show that it's not actually a part of our secant graph. It's just going to help us kind of form it. So a little bit lighter, maybe as a dashed line, is going to kind of help us out a little bit. So if we know that the secant is the reciprocal of the cosine, we can look at some of these critical points here. So if I look at the ones that are zeros right here at pi over 2, negative pi over 2, 3 pi over 2, etc., if we think about putting that into the reciprocal part, if you do 1 divided by 0, that's undefined. So when we look at a graph of something that's undefined, that usually shows up as an asymptote. So everywhere along this graph that had that cosine value that's 0 is actually going to have a secant value that's undefined. And if you were to go along your unit circle and actually do all of the secant values, if you were to go to, for example, pi over 2, and you look at the value, you know at pi over 2, it's the reciprocal, you would just do 1 over 0 and you would see that it was undefined. Some of the other critical points to look at are our 1s and negative 1s. So we know at 0 the cosine of 0 is 1. If we do the reciprocal of 1, 1 divided by 1, that's just 1. So that's actually going to have that point as a part of the graph. Same thing if I do the reciprocal of -1. Reciprocal of -1 is just -1. So all of these points that I'm drawing in blue are actually going to be points on our secant graph. So now if I think about some of the other points, and you're not going to have to do this for all of them, but if I think about, pi over 3, if we go over to pi over 3 on the unit circle, we know at pi over 3 the cosine value is 1/2 on that. So if we think about the reciprocal of 1/2, reciprocal of 1/2 is 2. So you're actually going to have a value here. Same thing if I go to negative pi over 3, that value reciprocal is going to be 2. If I fill in a bunch of the other points, if I were to go to like pi over 6 and do the reciprocal, it would be up here. And what actually happens is it forms a curve inside that asymptote with that 0.01 as our relative minimum. If I go over here to the pi, again, I could fill in some of those values, but what's going to happen is it's going to kind of almost, invert that little curve part of the cosine graph. Same thing over here, over here, over here, up here, and so forth on it. And this in blue ends up being our secant graph. If you know that one, that means you can also do the cosecant. Again, if you think about the cosecant, we know the cosecant is the reciprocal of the sine. So if we know how to graph the sine, it starts at 0, 0. At pi over 2, it's 1. At pi, it's 0. 3 pi over 2, it's -1. That's one period of the function. That's 2 pi. Again, I could keep going with my points. Just like before, I'm going to graph it just kind of dashed to show that it's not an actual part of our cosecant graph there. but it's going to help us kind of guide it. Same points as last time though. If we think about at 0, 0, if I do the reciprocal of 0, 1 divided by 0, that is undefined. That's going to be our asymptote. So at pi we have an asymptote, at 2 pi we have an asymptote, 3 pi we have an asymptote, and so forth. Just like when we did the secant graph, if I look at 1, -1, 1, and so forth, those reciprocals are just the same. And you don't have to fill in all the points. We're not going to make you fill in all of the rest of these points here as far as like the exact values when you do the reciprocal of 1/2 is 2 and everything. All we're going to make you do is just put in the curve inside that asymptote. So we've got one there. This one's going to go down. This one's going to go up. Notice that it has concave up and concave down parts of it. We're going to look at that a little bit later when we do some graph analysis. And we've got our cosecant graph. Notice that the period of the secant and the cosecant is still 2 pi, just like the sine and cosine graph. It would go from like here 0 over to 2 pi. It completes one full section of the graph and then repeats that. Same idea when we do our transformations. I'm going to flip it over here. And if I do 2 times the cosecant, if we graph the transformations, really we are just going to start by graphing the reciprocal one. Same thing with the amplitude changes and the period changes and everything. What we're going to graph is 2 times the sine of x. Just like normal, just like we did in our last unit. So if we're doing 2 times the sine of x, we know it starts at 0, 0. There's no period change to this here, but there is an amplitude change. So at pi over 2, it's going to go up to 2, back down to 0, and so forth with these. Okay, again, I'm going to graph it in just kind of as some dashed lines here, or dashed curves, I guess I should say. Okay, so we've got our regular 2 times the sine of x, but if we want the cosecant, we again think about the reciprocals of them. So here's like the 0, 0s again, all of our zeros going along here. If we take the reciprocal of that, it's going to be our asymptotes. And because this one had an amplitude change to it, that's going to affect our relative maxes and mins all along the way. But again, notice those like peaks and valleys, those are still going to be the same points on like your sine and or on your cosecant and your secant graphs there. So again, you don't have to fill in a bunch of points for it, but notice that it's still those curves. So you can draw in the rest. And then everything in blue here is our cosecant graph. So this is 2 times the cosecant. I'll do 1 or 2 more here. We'll take a look at it. Again, same idea for this one, except here it's the secant. We're going to do the cosine. So I'm really going to start by graphing the cosine of 2x plus 2. So since it's plus 2, we're going to move the midline up. Still has a normal midline with it. Notice it has the 2x on the inside. That means the period is going to change. So since that value, b value, is 2, it's going to shrink it. It's going to compress it by 1/2. So it's cosine. It's going to start up above 1 above the midline. But now all of those distances are going to be halved. So this one's going to be quite a bit compressed in here. Do our points in the other direction here. Going kind of quick, don't make any of the little mistakes with it here. And again, I'm going to draw in the cosine graph. Okay, so we've got our cosine graph. Now when we look at it, it's the same idea, except we're not looking at the zeros necessarily. Here, our whole graph, our midline moved up 2. So these are really the points that we're looking at. that make our asymptotes. So we're going to have more asymptotes in here. Notice because the graph was compressed that our asymptotes occur quite a bit more often. This one's going to look kind of messy here. And you don't have to fill in every single one on here. Oops, sorry. But again, that goes through, really it's those points of inflection, or those points along the midline here on that cosine graph. Now again, same as the last one, these maxes and mins are going to form the maxes and mins of the secant graph here. And it flips up and goes in here, down here, up here. Again, you don't have to do every single one. I'm just going to do a few of them in here, but same in the other direction. And again, just like the cosine graph was compressed, the secant graph is also compressed. So this one, the secant graph, is in red, contained within those asymptotes there. I'm going to do one more here. We'll just do the next one here, 1/2 times the secant of 1/2 x. So again, I'm going to start by graphing the reciprocal one, the cosine. So here the midline doesn't change. We don't move up or down any, but we know we have an amplitude change. So it's going to be compressed vertically. It's only going to go up to the 1/2. And we have a period change, but this time the b value of 1/2 actually means that we are stretching it. So if it's the cosine graph, I'm going to start up here. Instead of at 0, 1, I'm going to go up just a half up and down above there. Then again, normally I'd be pi over 2 away, but since we are stretching that, I'm pi away. Next point is going to be down at -1/2 and over. And here again, we're going to go down to 0, -1/2, and back up at 0. So this one is compressed vertically. It's only going to go up and down to a half. So that amplitude is 1/2, but then it's stretched horizontally because that period change, as the b value is 1/2. So our new period of the function is actually 4 pi. But we're doing the secant just as before. If I'm looking at those values that I would do the reciprocal right here, those would be undefined. So those are my asymptotes. And once I have those in, I'm going to look at the local or relative maxes and mins here. And again, you don't have to do all of them, but what's going to happen, since it's stretched out, it's going to be a little bit wider of a U shape in here than the other ones. Again, it doesn't have to be perfect. We're not going to make you put all those points in, but it does end up being wider. It almost looks kind of like a parabola type shape in it, but it's a little bit wider because of that 1/2. The rest of them, again, follow the same idea. You can move them left and right. You can move them up and down. Really, you're just graphing the sine or cosine graph first, looking for those points of inflection on there, or those points along that midline, same idea, and that's where our graph is going to be undefined. So we'll look at them a little bit more later. We'll do some graph analysis, but hopefully this kind of helped at least get us started on the secant and the cosecant graph.